Welcome to Numericals Hub. In this video, we're going to look at homogeneous equations. We will look at what do we mean by homogeneous equations and when is an equation said to be homogeneous. Later in the next video, we will be able to test for homogeneity. So, when the right hand side of the equation, let's say dy dx is equal to f of xy, can be expressed as a function of the ratio y over x only, when this right hand side can be expressed as a ratio of the function of the ratio y over x only, then the equation is said to be homogeneous. Such equations can always be transformed into variable separate equations by the change of dependent variables. We'll be able to see that later in the video. Therefore, homogeneous differential equations are of the form dy dx is equal to f of xy all over phi of xy, where f of xy and phi of xy are both homogeneous functions in x and y of the same degree. What do we mean by that? We mean that if you have an equation, let's say for example, I'll do it over here. If you have an equation, let's say for example m of xy dx plus n of xy dy is equals to 0. This equation here, let's say that m now here is what represented by f, and then n here is what is represented by phi. So when m and n are homogeneous, the whole equation here is homogeneous. And we can also see that homogeneous equations are always represented that dy is equals to 0. If you have an equation such as m x of y dx plus n x of y dy is equals to some g of x is equals to g of x, then this equation here is not homogeneous, while this one here is homogeneous. Join me in the next video to see how we can test for homogeneity.